this is a direct follow-up from the last video. So let's practice drawing a mechanism for a nucleophilic acyl substitution reaction. And I can't stress enough how important it is to practice a bunch of these different mechanisms. So be sure to work the board and homework problems for this section so you get some practice drawing these mechanisms. All right, so we want to propose a plausible mechanism for this reaction. So I'm converting this carboxylic acid into this ester. I'm doing this in acidic conditions. So essentially I'm replacing the OH with an ethoxy group, but the ethoxy group directly can't be my nucleophile because I can't have OET minus present because I have basic conditions. So the ethanol is going to have to be my nucleophile. Now remember, we have two core steps. So we have to do nucleophilic addition and the loss of a leaving group, but then we have to decide both before the nucleophilic attack, in between the nucleophilic attack and loss of the leaving group, and after the loss of a leaving group, whether or not we have proton transfer. Right? So we know we're going to have nucleophilic attack. We know we're going to have loss of a leaving group, but do we have a proton transfer here? Do we have a proton transfer or proton transfers in between the two? And do we have a proton transfer at the end? So the first one is easy. Whenever we have acidic conditions, we almost always have to start with a proton transfer. So the protonated ethanol is going to be my proton source in this case. I can't just use ethanol as a proton source, because if I try to use ethanol as a proton source, when it gives up the hydrogen, that's going to make an ethoxy group, right? I can't create a negative charge on an oxygen when I'm in acidic conditions. So after protonating my carboxylic acid, I have this. So then my next step will be nucleophilic attack. All right, then I know, right, this is the oxygen that was part of the carbonyl group, so it's going to reform the carbonyl group. This is my new, this is my nucleophile. This is what I'm replacing the OH with, and so this OH is my leaving group. So I know I need to lose the leaving group, but do I need a proton transfer? And the answer is yes. I can't just pop off an OH because that's going to be an OH negative. I can't produce an OH negative when I'm in acidic conditions, so I'm going to need to protonate this OH first. But I can't protonate the OH while I still have the positive charge here, because that's going to give me two positive charges in the same compound, and we said we can't do that. So I'm going to need actually two proton transfer steps here. I'm going to need to take the hydrogen off here, then I can protonate the OH. So first we deprotonated that guy. All right, now I can protonate my leaving group. Okay, now I'm ready to take the leaving group off, so I can have my loss of a leaving group. Okay, so I've finished this point. Now the last thing I need to do I need a final proton transfer? And this guy is charged, so I do. So to get to my final product, I'm messing up there. And that will give me my final product. So I think I've said this 100 times already in the videos. It takes a lot of practice. So be sure to work the example problems for both the board work and the homework so you can see different examples. And so you can start to get a better idea of when you need a proton transfer and when you don't.